Okay, so question 2 might look a little more difficult than question 1 because question 2 not only involves a transition metal, but it also involves a polyatomic. What really can help you out here is that we should always keep our polyatomics in parentheses, because the parentheses tells us that this SO4 is sticking together no matter what. Okay, so no matter what this reaction is going to do, SO4 is going to be together no matter what. So treat it as if it was just one single element. Now, in your transition metals, they give you the charge because you don't know the charge unless it's given to you, or unless you're some crazy high-tech scientist that can do all these kinds of experiments to figure out the charge. But luckily for them, they can just give us the charges and we can go on about our merry little life. Okay, now to know this guy's charge, we use our polyatomic reference sheet. And if you don't have that, in this flashback, I was nice enough to go ahead and give you the charge. And so in this particular example, I'm going to do the same thing. So we see that SO4 has a charge of -2. Now remember, in double replacement reactions, an element from one compound is going to switch places with an element from the other compound that it's reacting with. Now remember, elements of like charges switch places. So positive will switch places with the other positive, and negative will switch places with the other negative. But remember, we only look at the positive one because it's easier that way. So we know that right here in this compound, Ag is our positive. So I need to determine over here who's my positive and who's my negative. Well, I look for Li. I see that it has a +1 charge, so he's my positive. And Br, I find right here on the periodic table, -1 charge, so he's our negative. So that means Ag, being positive, is going to switch places with Li, being our other positive. Make more room here. So it's going to be Ag with Br and Li with SO4. Keeping SO4 in parentheses because it's polyatomic. These guys are going to stick together no matter what. Keep it in parentheses. We can treat it like it's one element, make it easier on ourselves. Remember, we write this Li and then SO4. We don't write SO4 and then Li because the guy who is positive, which is Li, is always written first. And the guy who's negative, which is SO4, is always written second. So it's LiSO4. Now, I'm not done just yet. I have one more step to do, and then I'll be completely finished with this problem. I have to do crisscross rule to make sure my formulas right here are written correctly. So let's start with AgBr first. Okay, Ag I know has a charge of +1. It tells me that because it's a transition metal, so it tells me. Br's charge I can find from the periodic table. I found to be -1. And then I'm going to switch the numbers. Bring the 1 here, bring that 1 here to give you Ag1, Br1. Remember, we typically don't show the 1s, so it's just Ag, Br. So he's already written correctly, so that worked out well for us. Now let's look at LiSO4. Okay, Li, I found its charge to be +1. SO4's charge is a polyatomic. I can look on my reference sheet to find its charge, but here it already gives it to you in the problem as -2. Okay, so when you switch them, just bring this 2 right here and this 1 down here to give you Li2, SO4, 1. Remember, we don't typically show the 1s, so it's just Li2, SO4. So 2 should squeeze in right there. And now we have successfully predicted our products for this double replacement reaction. AgBr plus Li2SO4. So use this process to help you answer question 2 correctly.